Hi teachers, thank you so much for joining us today. My name is Jeff Gobin and I'm the Engagement Manager for Braining Camp. I was in public education for about 17 years in various roles, including being a second grade teacher, fourth grade teacher, and most recently I was a campus math specialist and instructional coach. I joined the Braining Camp team about 1 year ago. My school district purchased a Braining Camp license during distance learning, and I found myself using their digital manipulatives on a daily basis with both my intervention groups as well as whole group instruction. I really just loved having a way to build conceptual understanding, make math visible, and just increase student engagement. I'm super excited to share some of these strategies with you today in this session. The QR code that you see on the screen will take you to a Google Drive folder where you can find this presentation as well as some Braining Camp handouts and some other share codes that I'm going to be modeling with you today. Here's a quick agenda for today's session. We are going to start by walking you through the steps for redeeming your free Braining Camp class license, which is awesome. Next, we'll talk about the Lesh translation model and discuss the importance of using multiple representations in math. The majority of our time will be spent in Braining Camp exploring different ways that you can make math more visible for your students. Finally, we will take a brief look at Braining Camp's resources page to explore the different tutorial videos, teaching ideas, and lessons that we already have on our website. And here are those steps that you see on the screen for redeeming your license. We can just go to brainingcamp.com, click redeem, and you're going to enter in that code BMM2025. Your class license will last all the way up through June 10th, 2025. So basically through the end of the year, you and your students will have full access to everything on Braining Camp. Next, I'm actually hop on the website and demo how to redeem your code. Here we are on brainingcamp.com. I'm going to go ahead and click redeem code and enter BMM 2025. Click Submit. It's going to ask for your email address and a few other questions. Then you will have full access to all 17 manipulatives. Today we're really going to focus on the 4 manipulatives that you see on the screen: the base 10 blocks, place value disks, fraction tiles, and fraction circles. I chose these 4 because of their versatility. They can be used for representing numbers or fractions. We can make computation visible, and all 4 of these also feature customizable options, including switching from whole numbers to decimals. Because this session is for 3rd through 5th grade teachers, I'll be modeling a variety of different concepts appropriate for students in that range. Throughout the session today, you're going to see me model numbers in a variety of different ways. If you're not already familiar with the image on the screen, this is called the Lesh translation model, and this model really features the 5 forms of representation in math: the physical, the visual, the symbolic, the verbal, and the contextual. And making connections across these different representations is really essential to learning. If you've not checked out this book called Principles to Action, highly recommend this book. This was a publication from NCTM, and I found the section on tools and technology especially interesting as it really applies well with using digital manipulatives. To help make sense of the Lesh translation model, we are actually going to hop onto Braining Camp and make a similar model using the manipulatives. All right, here you can see the model that I created. We are going to begin with a symbolic example of 4 times 3/5. This equation is very abstract, and students often confuse the different algorithms that they have learned for fraction computation. For the visual representation, I'm going to add a number line to the workspace. Because I'm using fraction circles, a fraction number line will appear. I'm going to make this number line longer by stretching it out. Because we are multiplying by fifths, I'm going to adjust the partitions. To show the multiplication, I'm going to add a hop to the number line. I will stretch it out and label it 3/5. I'm going to copy that hop 3 times to show my 4 groups of 3/5. For the physical representation, I'm going to use the fraction circles. I'm going to start by adding the first fifth to the screen. You can click to add rapidly. I'm going to select my first group of 3/5 and copy. I'm going to use the fraction circles to solve the problem by combining my groups of 3/5. The pieces will snap together or can be rotated. I see now that I have 2 and 2/5. To match the color of the fraction circles, I'm going to change the hops to be green. For the contextual representation, I'm going to give a sample word problem that aligns with 4 times 3/5. My favorite show on Netflix is 3/5 of an hour long. How long will it take to watch 4 episodes? Providing context allows students to make connections with the math that they're doing. Now that we have some context, let's look back at our physical and visual representations. I see that I can add red whole circles above each group of 5/5. This helps me to visualize 2 and 2/5. I can also see that I have 2 and 2/5 on the number line. The verbal representation provides an opportunity for math discourse and for students to explain their thinking. For my example, I am typing, the answer is 12/5 or 2 and 2/5. I know this because... Now that we have completed the model, let's pause for a moment. Try to identify any connections that we can make between the different representations. The first connection that I made was between the contextual and the symbolic. Having a relatable word problem provided a reason to multiply 4 groups of 3/5. My second connection was between the symbolic and the visual representations. The hops provide a visual to actually see the 4 groups of 3/5. I know that 4 times 3 is 12, so seeing 12/5 as an answer makes sense. The number line also helps to see multiplication as repeated addition. Making math visible like this can help students make connections with mixed numbers and improper fractions as well. Students may remember that they can multiply the denominator by the whole number and add the numerator to get an improper fraction. But if we're only teaching students an algorithm, it's hard to expect them to build a conceptual understanding. Using manipulatives can also help students convert an improper fraction into a mixed number. Students may have learned that 12/5 is equivalent to 12 divided by 5. They can determine that the answer is 2 remainder 2. By using fraction circles, though, students can actually see the 2 whole circles with 2/5 remaining. The Lesh model could become a valuable resource in your classroom as you create anchor charts for introducing various math concepts. The next manipulative that we are going to explore is base 10 blocks. Similar to fraction circles, once you get the first block where you would like it, you can click to add rapidly. Turning on the workspace labels will display the standard form of the blocks. Turning on groups will display the value of each individual block. Snapping the blocks together is a great way to model expanded form. By default, whole numbers will be represented by the blocks. You can switch to decimals by selecting number set in the corner. The blocks themselves will not change, but the workspace and group labels will update. I'm going to use this example on the screen to model in different ways. I'm going to start by showing the word form. Making your students read this correctly as 3 and 24/100ths rather than 3.24 will help them as we write it as a fraction later. Next, I'm going to enter in the expanded notation. Students can use the blocks as a visual to help with this process. Next, I'm going to rewrite this number as a fraction using the number and fraction input tools. You can use the keypad on the screen or enter numbers with your keyboard. I'm also going to add a customizable number line to the screen. I'm going to turn off the setting of scale to manipulatives as I'm not actually placing the blocks on this number line. I'm going to change the maximum to 5 and stretch out across my screen. Finding the approximate location can lead to some good math talks with your students. The annotation tools can be used for finding halves and fourths. I'm going to place an arrow where I think 3 and 24/100ths would be located. Finally, we are going to have students discuss what are some contextual examples of 3 and 24/100ths. Students may mention the cost of a grocery item, how many hours it takes to grandma's house, or how many miles they traveled on a bike ride. Seeing decimals in real life situations can help students make sense of a difficult concept. Which forms of representation do you see on my screen? Are there any connections that you can make between the models? If you would like to save your work, there are several options for teachers and students. To see these options, click the blue Share button in the corner. You have the option to copy the image of your workspace, download the image, or create a share code. Creating a share code will open an 8-digit alphanumeric code that you can copy into a safe place. Next, I'll show you where to enter a share code. There are 2 different share codes that I'm going to model today for base 10 blocks. These are activities that I have made that you could use in your classroom. All of the share codes can be found in the presentation. The first activity is for decimal place value. To access this activity, simply copy the 8-digit code and paste it into the Braining Camp homepage in the share code box. To begin this activity, we need to spin our spinners to determine the number we are building. You can spin them individually or at the same time. And there you can see that I spun 9/10ths and 8/100ths, so I'm trying to build 98/100ths. Add the first tenth to the screen. You can select it and stretch it out to show 9/10ths. Next, we will add our hundredths. Again, you can place the first one into place and then stretch it out to show 8/100ths. Hopefully, students will make connections when they realize the standard form, fraction, and word form all read 98/100ths. This was obviously a very quick task. If you're using this as a teaching tool and would like to try another example with your students, click the Reset button. This will restore the share code to its original state. We will talk all about the amazing workspaces later, but to choose this one, select Grids from the Workspace menu. Next, let's check out partial products. Once again, I'll just copy this code to launch the activity. For this activity, students will randomize the numbers to determine the array that they're building. The number generators are set to build an array that will fit in the frame. So here we have 28 times 15. Once you get this first unit cube into place, you can click to add rapidly. The 10 rod can be rotated so that it fits, and again you can click to add. We will continue building the rest of the array. And as you fill in the bottom, life hack, highlight what you have in the top of the array frame and copy it as many times as you need. It's going to save you and your students a ton of time. Next, we will begin filling out the partial products using the expanded form of our 2 factors, 20 plus 8 and 10 plus 5. As you begin filling out the partial products, you will see that I've color-coded the inputs to match the color of the base 10 blocks. To complete the activity, students would add the partial products on the screen or in their math journal. I'm going to delete the directions so I have more room to model. You can see that I now have the standard 2x2 digit multiplication algorithm on the screen. I'm doing this to help students make connections. 8 times 5 is 40, 5 times 20 is 100, 10 times 8 is 80, and 10 times 20 is 200. We add those up for an answer of 420. You can check your work in the factor track by selecting it and turning on the labels. Next, I'm going to add up the partial products. 300 plus 120 is 420. So now within this one problem, we have a concrete, pictorial, and abstract representation. This is another activity where the reset button could be utilized if you'd like to try another problem. Next, we're going to dive into one of my favorite manipulatives, place value disks. By default, you will see whole numbers represented to the millions place. You can adjust what is in the bin by selecting maximum and selecting the disk of the highest value you would like. You can also change the bin by selecting decimals. You can adjust what is in the decimals bin by selecting minimum and making your changes. Similar to the other manipulatives, you can click to add rapidly. Turning on the workspace labels will reveal the standard form. The place value disks also feature a break and regroup option. You can point out to your students that the standard form is not changing. So far, everything that I've modeled has started with a blank canvas, besides the 2 share codes. Make sure to check out the workspaces unique to each manipulative. This is where you can find some really great teaching tools. We are going to start by exploring the place value workspace. Just like the Manipulatives bin, the place value chart will adjust as you choose a maximum or minimum if you're using decimals. We'll go with thousands. The discs will move into the correct place when clicked on, providing a great way to build numbers quickly. They will also automatically break when moved to the place to the right. Are you looking for a great math talk with your students? Turn and talk to your neighbor. Why does the standard form remain the same when the discs are being regrouped? Understanding regrouping is a huge concept that you will see in the next few minutes as I model subtraction and long division, both with place value discs. Just like the basic workspace, the place value workspace can be changed to work with decimals. You can adjust the chart and bin by selecting minimum. Next, let's explore the subtraction workspace. I'm going to switch this back to whole numbers and adjust the maximum to 100. The height and width of the subtraction workspace can be adjusted. I'm going to add a subtraction problem to the top of the screen. 800 minus 379. I'm going to leave it horizontal so the students can see the regrouping in action without worrying about connecting any algorithms yet. I'm going to start by adding 800s to the screen. We don't have anything in the tens or ones place, so we need to regroup all the way from the hundreds place. Now that we have enough ones, we can subtract 9. Drag the discs into the bin at the bottom. Subtract your 7 tens and your 300s. Students can see that 379 has been taken away. They can also see the difference of 421 shown at the bottom. You can hide the answer by selecting the subtraction mat and turning off the labels. I'm going to pause the recording and get another problem set up. We are now going to complete another example, but actually make connections with the algorithm. I have added inputs above each place. We will start by adding our number of 735. Students will see in the ones place we do not have enough ones to take away 8, so we will regroup. Now we have 2 tens and 15 ones. We'll take away our 8 ones, and we are left with 7. Next, we look in the tens place. We cannot take away 6, so we will regroup. We now have 6 hundreds and 12 tens. We will subtract our 6 tens. We are left with 6. And finally, we will subtract our 200s and be left with 4. And if you like this activity with the colored inputs, I've added a bonus share code to the screen if you would like to try it with your students. Now we're going to check out a few share codes with place value discs, starting with this number of the day through the 10,000s place. This is a share code that I would recommend doing as a math warm-up or instructional routine. Begin by spinning the random number generator. Use the place value discs to represent the number 57,847. Once the number has been built, you can click the eye on the blue cover tool to check your work. Next, we will input the expanded form, and you will see that I've color-coded the inputs to match the color of the place value discs, in case students can make some connections that way. Next, we will type in the word form. And then we will fill in the place value chart with different ways that you could decompose and represent your number. So we'll start with our 5 10,000s and 7,000s and so on. And then what you can do is you can actually use the place value disks on the chart to model that regrouping like you've seen several times, where the disks will automatically regroup. And we'll do one more representation there. We'll go ahead and bring over that 10 and regroup it. So now we have 5 10,000s, 7,000s, 700s, 13 10s, and 17 ones. Now, before we get to the final step of rounding, I'm going to bring all of the place value disks back to where they were originally so that we can use the place value chart really to help us with rounding. To round to the nearest 10,000s place, I can see that I have 7,000s, so I will add one more to the 10,000s to make 60,000. I can see that I have 800s, so I'll round up and add an additional 1,000 to make 58,000. I only have 4 10s, so I will not add an additional 100. This will round to 57,800. I can see that I have 7 1s, so I'm going to add one more to the tens place to make 57,850. This number of the day activity would best be utilized as a teaching tool with your students. If there are any changes you would like to make to this existing code, you can. Make your edits and then create a new share code. Make sure to copy the 8 digits into a safe place so you can access it later. There's one more share code I'm going to model with place value disks, and that is for long division. This really is an activity that I wish I would have known about years ago when I was a 4th grade teacher. You can see that we have 2 problems on the screen. I'm going to work out the first example without making any connections to the standard algorithm. We are just going to work it out conceptually. If you have never modeled division conceptually like this with your students, I cannot recommend it enough. So many students get turned off by division because the algorithm does not make sense to them. I used to introduce division like this when I'd model lessons as a math specialist, and I've watched several 4th grade teachers have light bulb moments. This is not new math, this is just making an incredibly abstract concept visual for your students. We are going to start by dividing our 300s. The break feature modeled earlier is going to be super helpful for this task. And now we have 12 10s that we are dividing equally between our 2 groups, so each group gets 6. Next we will divide our 6 1s, so each group gets 3. And now you can see the quotient of 163. For the second problem, we are going to pause between each step and make connections with the standard algorithm. First, we will divide the 800s between the 4 groups so they each get 2. Next, I'm going to grab the pen tool and change the color to green so I can annotate where we see the division problem. So what we just did, we just gave each group 2. We already shared 8, and as you can see on the screen, there are 0 green hundreds remaining. I'm going to change the color of the pen to magenta. The step of bringing down the next digit is so abstract for kids. Here they can actually see the magenta colored disks that we will be dividing next. Alright, so we'll go ahead and continue dividing our 10s. So each group will get 1. We'll go ahead and finish the algorithm steps. So we have subtracted 4. We have 1 remaining, which you can see on the screen. We'll go ahead and break up our 10. Grab our marker so we can identify now that we have 12 1s that we're working with, so I'm bringing down that 2. In the last step, we're going to take those 12 1s and divide them into 4 equal groups. I'm going to speed up this section of the video. We all know 12 divided by 4 is 3. And there you can see the answer of 213. Just like all the other place value disk activities I've modeled, you could also have students practice dividing decimals. To get the division sign like I have, I just added line segments and rotated as shown. The last manipulative that we are going to explore today are the fraction tiles. When you add the fraction tiles to the screen, you will see several different labeling options. Fractions, of course, decimals, percents, and blank. I'm going to go ahead and leave this on fractions for now. I'm going to add another half to the screen, and this time I'm going to turn off the fill. I'm going to copy this 5 times so I can show different ways to model equivalent fractions to 1/2. And just like all the other manipulatives, once you get that first one into place, you can click to add rapidly. I'm going to pause the recording quick and put up a problem. Here you can see that I've added 11/12 minus 3/12 to the screen. To solve this question, I'm adding a number line. Because I'm in the fraction tiles manipulative, a fraction number line will be in the tool bin. I'm going to go ahead and add 11/12 to my number line. And to illustrate the subtraction of 3/12, I'm going to highlight 3 and I'm going to turn off the fill. That way the students can see now that I have 8/12 remaining on the screen, but they can still see the original fraction of 11/12 that was shown. You're probably all thinking that 8/12 can be simplified, and you are right. I could change 8/12 to 4/6 or 2/3. Another difficult concept I love modeling with the fraction tiles are improper fractions and mixed numbers. Here you can see I am adding a bunch of eighths to the screen, 14 to be exact. I'll go ahead and add the fraction tool here, and I will enter that in as 14/8. To help students convert this to a mixed number, I'm going to use the red 1 whole fraction tiles. Placing this on top reveals our new mixed number of 1 6/8. Of course, this fraction can also be simplified. We can place our 4th tiles on top to reveal our new fraction of 1 3/4. There are so many other amazing concepts that can be taught with fraction tiles. These are just a few of my favorites that I wanted to showcase. There are 2 fraction tile share codes that I wanted to model quickly. The first one is for equivalent fractions. So this share code is very similar to what I just modeled using the fraction tiles, but this is a good example of a share code that students could complete completely independently and then save their work. They could enter in the numerator and denominator as shown, but we'll just pretend for a minute that this entire activity has been completed. Students also have the ability to click the Share button. The same options will appear for them. They can copy the image if you have a Google slide deck that everyone's collaborating on. They can download that image and upload it to whatever platform your district uses. Students can also create a share code if they want to continue their work at home or show their parents. They have the option of copying a direct hyperlink or the 8-digit code like you've seen a bunch of today. And the very last share code that we are modeling today is adding fractions with unlike denominators. This is another activity that you could use as a teaching tool or an independent assignment for students. Students use the fraction tiles to build the question as shown. Students then use the fraction tiles to try and find a common denominator. Exploring this conceptually before introducing an algorithm is a great way to help students visualize the math. If you do not teach adding and subtracting with unlike denominators in your grade level, this might be a fun enrichment activity for your students to try. You might be surprised what your students can figure out when they have the fraction tiles to use as a visual. The last item that I want to briefly explore with you today is the resources page. Today's session was all about making math visible for your students. There is still so much more to discover on Braining Camp. The Tutorials tab will take you to videos for getting started, Braining Camp Live, tasks, adding students, and share codes. Each manipulative also features its own 2 to 3 minute video to get you started. You could even show these videos to your students before trying a manipulative for the very first time. We also have around 300 pre-made tasks available on our website that are available for teachers. These are sorted by grade level. I chose 4th grade, and I'm going to scroll down until I find one of my favorites called Color Me. When you open the task, it opens a 2-page lesson plan. It provides a description, a share code, an image, directions to launch, directions for the task itself, some troubleshooting, and questions to facilitate math talk. We have recently added a new Ideas tab. This is a great place to look for ideas on how to use digital manipulatives with your students. Each video comes with a share code if you'd like to try it yourself. We also have all of our webinars on demand that you can watch at any time. These webinars are led by the Braining Camp team as well as math industry experts. The last tab will take you to our blog where you can learn all about how to use manipulatives, best practices, and so much more. I hope you've enjoyed this session today and have learned how you can make math more visual for your students. I know that we've squeezed in quite a bit today during this 30-minute session. Don't forget that you can go back and rewatch certain parts of the video if needed. All of the share codes modeled today can be found in the presentation linked up in the Google Drive. The QR code below will take you to a brief feedback form about today's session. We are constantly trying to improve here at Braining Camp and really do read through every submission. I also encourage you to follow us on social media for product updates and more teaching ideas. My email address is also on the screen. Please do not hesitate to reach out if you have any questions. I am passionate about helping teachers and want to hear from you. Special thanks to Christina Tondevold for letting me be a part of this year's virtual math summit. This was a fun experience and I would love to do it again. Lastly, teachers, thank you for everything you do to support your kids each and every day. Have a great rest of your school year.